Another type of problem we get is with the disc, and these are very, very common. So we have three models here that we use to demonstrate a disc. So let's talk about the disc. The disc primarily is a shock absorber. It's a cushion between the two vertebrae or the two bones in your spine, and it's designed to absorb shock. As well as that, it actually takes part in the movement of the joint as well. So it's not just a shock absorber, it actually contributes to the dynamics or the movement dynamics of the joint. Now, because you have a disc in here, it helps to create space through which the nerve comes through. Now, something very interesting about the disc. Number one, you'll see if you look here that there are pores in the vertebra, and these pores are there to create a fluid transfer between the bodies of the vertebra and the disc themselves. So when you compress the disc, the fluid moves out of the disc into the body of the vertebra. When you decompress the disc, it sucks the fluid back in. That's a hydraulic system. Now, that's one thing. Next thing we need to look at is something called the nucleus. Inside the disc is a nucleus of fluid, and you'll see that there's actually rings around the nucleus. So although there's a fluid interchange between the vertebra, there's also a fluid nucleus around which the vertebra functions. Now that might seem like a bit complicated, but I've tried to simplify it so you understand how important this is. When you get problems with your discs, you can get different types of problems. One is where the nucleus actually shifts and pushes through these enclosing fibers and moves off to one side, and that can actually cause a bulge which puts pressure on the nerve. A good example of that would be sciatica, pain down one leg or pain down both legs, where you actually have a bulging disc from a displaced nucleus. The other type of problem you can get is where you get simply just overall compression of the disc. Now when that happens, when you get this overall compression, you're not getting the fluid interchange between the two bodies, two vertebral bodies. So what actually happens, because you're not getting the fluid interchange, no fluid means no lubrication, so the disc starts to wear. And as the disc begins to wear, as you can see from the model on the right here, you get different degrees of thinning. And surgeons, when they do operations and they might actually remove the disc, say it smells really bad. It smells like really bad old leather. And you can see what's actually happening in these models, where as the disc begins to thin, it begins to harden, and you're not getting the fluid into the disc. So what we try to do when we see disc problems, in particular the compression, is we try to separate the two, and we have a special couch which we use here, and we also have a special device that people lie on that actually decompresses it to actually get the separation between the two and suck the fluid back into the disc. Now of course there are different degrees of degeneration or wearing of the disc, and as you can see here, that as the disc begins to wear, you get calcium build up and you get these spurs forming. Now if we look over here on the chart, you'll see an x-ray here of the side view of your neck or the cervical spine, and you'll see down here is the diagram to show what it looks like. The space of course is the disc, and when you lose the curve in your spine, as it begins to straighten, that's the first stage, phase 1 of degeneration, spinal degeneration. As it begins to degenerate further, you get a thinning here of the disc and the little calcium beaks forming there, which we call osteophytes or spurs. And so the degeneration continues, and you can see that actually happening here, where that's a fairly normal space, and that's starting to thin. You're getting the little beaks, and there's the beaks forming even further. So that's in the neck, because you have discs in there too. But of course we're talking here about the lumbar spine, but you can have that in any part of your spine, because there are discs right from the top right to the bottom. So what we try to do obviously is to get fluid back in there. Now if you have a fracture, you put the two bones together and they're meant. That's how the bones are actually meant to work. Now in my view, my opinion is that as these discs begin to thin, that begins to behave like a fracture, and so the two bones start to mend, and then you can actually get a big restriction of movement. Now what actually happens, you can see the opening there through which the nerve comes through, but something else occurs, that as that gets thinner, so the opening through which the nerve comes through begins to reduce, and you're getting a lot more pressure on the nerve, not just from the disc bulge in here, but also from the calcium buildup in there. So that's basically the history of the disc and how we endeavour to improve disc problems. If there's a bulge, which I said before, just on one side, that can be caused by the bones being out of alignment or the muscles pulling unevenly on the spine. And so either way, you've got to decompress the disc, whether it's a total compression or whether it's just a bulge on one side pressing on the nerve. Now we're going to, that's the mechanical aspect of the spine. At a recent seminar I went to by Professor Joseph Schaefer, he threw a total new light on how these problems are caused. Now we always thought they were caused by wear and tear, by injuries, by mechanical overload on the spine, lifting, etc., etc. And so we always thought they were caused by mechanical means. But at this recent seminar I went to, he revealed a whole lot of new research which shows that that is not the only cause of disc problems. So in the next section we're going to go into that. Thank you.